Today we're going to begin investigation 2 of kaleidoscopes, hubcaps, and mirrors. And in investigation 1, we looked at 3 types of symmetry. We looked at reflection symmetry, rotation symmetry, and translation symmetry. And in this particular investigation 2, we're going to specifically look at symmetry transformations involving reflections. And we're going to use, in this case, a line of reflection. So this line M represents a line that we would want to reflect this 5-sided shape, which we would call a pentagon because it has 5 sides. We want to reflect it across this line. And so when you do that, when you reflect this across that line, you produce a mirror image. And that mirror image, that copy basically that we have of the original, is called a transformation. So we take the original image and we basically reflect it. Like if we were using a mirror, we would see it on both sides of the line, and so our reflected image would be seen just as it is, using the line M as a line of reflection. So you can see the original and then the new image reflected. So this new image is the transformed or transformation of the original image. So in this investigation, we're going to explore transformations associated with reflections, rotations, and translations. In this case, right now, we're just going to look at the reflection piece of it. So as we move on in this investigation, we're going to continue to look at this particular image. Now, the next piece of this is that when we describe line reflections, we describe them using the associated points. So we have one point here that represents B and another point which we call B prime, or the copy of B. And again, these are called line reflections. So we're going to look at line reflection symmetry that we have in this problem. And so you have a set of lab sheets. I'm going to actually go directly to the lab sheets for this. And we're going to start with lab sheet 2.1A. And for question A, it says copy pentagon ABCD, its image A prime, B prime, C prime, D prime, E prime. That's all these letters here, the different points, over as a reflection over line M. So we already have this line M that we're going to use as a reflection line for image A to image B. So the lab sheet's already done kind of the hard work for you in making the copy. And so now the next part is what we need to do. It says to draw segments connecting the vertex of A, B, C, D, E to its image. So what we're going to do is we're going to connect these copied pieces. So if we go from, I guess we'll start with A. If we go from A to A, I'm actually going to draw a segment all the way across from A to A. So that's what the first part of this is. And then from B to B. So I'm going to copy each of these points directly across to its corresponding copied point. So B to point B prime, and then C to C prime. So that little symbol above the letters are. So prime is like the first one, and then D to D to D prime, and then finally E to E prime, which is not much below where D was. So what I now have is lines connecting all of those points. Creates kind of an interesting looking image, but that's what we want to do in each of these cases. Now, that was for A1. We just answered or completed part A1. Then 2, it says use tools for measuring angles and lengths to see how the line of reflection is related to each segment you drew in part 1. And I think it might be kind of obvious if I go from point A to this reflection line, and I just measure that, I'm going to use millimeters because it's, or centimeters because it's easier. So from point A to that line is 4.6 centimeters. From here to that line. So if I go from there, that line to that line, it's 4.6 centimeters. And if I measure the other side from that point to there, you can see that that's also from this point to there is 4.6 centimeters. So that distance from the reflection line to there is 4.6 centimeters on each side. And if I go to B, do the same thing. It looks like it's about 1.8 centimeters here. And on the other side, it is also 1.8 centimeters. As I measure, so I'm just using a ruler to measure the distance in each of these points. We go down to C, measure from point C to the line of reflection. So like it's exactly 3 centimeters to the center line. And then another 3 centimeters on the other side. And then D, looks like it's 1.6 centimeters on this side and 1.6 centimeters on the other side. And then finally E, which is a pretty long distance. Looks like it's 5 centimeters on each side of that line. So if I go from here to here, it's 5 centimeters. From the center line to that point out there, E, and it's 5 centimeters from E prime to, again, the center line. Now, you might also notice the angles, and I really didn't use an angle rule, but this angle right in here, this angle right in here, all of these angles where I do these lines look like they are right angles, which means that they're 90 degrees. So if I take my angle ruler and set it on there, you can see that each of those angles is a right angle or 90 degrees. So this angle in here and this angle in here, and so all of these angles are right angles. And so what that tells us, the pattern that we see, is that the distance from A to the center line is the same as the distance from A prime to the center line, or line of reflection. And from B to the center line is the same as B prime to the center line. And from C to the center line, C prime to the center line, same distance. So what I basically find is that the distance from any point of the original design, so the distance from any point of the original design to the line of reflection is the same as the distance from the copied image points to the center line, or line of reflection, to the line of reflection. Now it's very helpful because now if I want to find the copy of any image and I'm reflecting it over a line, I know that all I have to do is find the distance at right angles. So this right angle part is somewhat important because I need to have them, it's called perpendicular or at right angles. So this distance and this distance are equal, but they are equal at right angles to each other. So if I'm trying to find or locate copied images over a reflection, actually draw them, then I can use those principles or those rules to help me find the new points of reflection. And that completes question A from problem 2.1. We're going to move on in the next lesson to question B, but we need these concepts, the idea of equal distance from the center line or from the line of reflection at right angles to find the reflected image of the new image, which we're going to look at in question B. So you can go on to that lesson next if you're done with this one.